We're going to do a second example from the homework regarding a hypothesis test for a mean with the population standard deviation, or sigma, is known. What's different about this problem is we're given the data rather than a summary. So we're going to see what that looks like. So we're going to work homework problem 12 here. I'm not going to go through the steps again. We did this in the last video. I will load those for each one of these hypothesis tests for a mean. But we'll notice we'll follow those same steps again for problem 12. Remember, we're given the sample data in problem 12. So if we come on down here, we'll see, here's the problem. The length of time in years it took a random sample of 32 former smokers to quit smoking permanently are listed. Assume the population standard deviation is 6.2. At alpha equals 0.02, is there enough evidence to reject the claim that the mean time it takes smokers to quit smoking permanently is 13 years? Notice I put the word is in bold and underlined it. That is the same as saying equal to. So this is my claim that mu equals 13. That's what written symbolically. Right away, since I see that my claim has equal, I know this is going to be a two-tailed test. So, and I know this is the claim. So I've located mu equals 13 as the null hypothesis, identified it as the claim right here. And then the complement of mu equals 13 is mu is not equal to 13. Again, this makes it the two-tailed test. The two-tailed test always, probably wouldn't hurt for me to say two-tailed test always comes from the null hypothesis. So I'm going to go ahead and put that in there before we move on, because remember, the alternative hypothesis lets me know what type of test I'm running. So what do we have in the problem? We have n equals 32. We don't have x bar because we have the data. So we're going to be able to calculate the mean of the sample. Remember, x bar is the mean of the sample. We are given the population standard deviation of 6.2, and we're given an alpha of 0.02. I was kind of in a hurry to get that last video up last night, and I don't think I made this as clear as I should have. I'll probably re-record that video after the semester. But in the meantime, make sure you always identify your alpha too. Is the population standard deviation given? Again, the answer is yes. And since it is given, we're going to use z-stats, but we're going to use it with data this time. After we rerun the test, we'll see a p-value of 0.303. So p equals 0.303. When compared to the given alpha of 0.02, we see that 0.303 is greater than 0.02. If the null is high, it must fly. So again, we're going to fail to reject. So let's see what this looks like on the screens. I went ahead and did the summary stats so you could see the mean right here of 14.12. I don't really need it because I'm going to be able to run my hypothesis test directly from the data with statcrunch. We said it was a one sample Z. My data is in variable 1 in this column, so I select the column. Now here's what throws everybody off. You're given the population standard deviation. Remember, this standard deviation up here is the sample. We don't want the sample, we want the population, because that's what we're doing. We're making an inference to the population. So we have to enter the 6.2 here where it asks for the standard deviation. Now, this is going to be frustrating because I'm sure if you've already tried it, you tried it without doing this and you got the wrong answer. And the reason I know this is because I made the same mistake the first time I used statcrunch. So remember, the population standard deviation goes here. Now, I'm doing a hypothesis test for mu equal to 13, and an alternative hypothesis is not equal to 13. And sure enough, here's my results. I get a test statistic of 1.03. Don't really need that to make my decision for this class, although some people prefer the test statistic method. Remember, the two methods are sisters. They both work on the probability generated from alpha. So the p-value is 0.303. So before we show the completed, let's try this in statcrunch. So here's the problem, and notice here's the data right here. I don't have to type it in. Remember, I'm going to click this to copy the table, and it's going to open it in statcrunch for me. There's my data. Now, I'm not going to do the summary stats again, but I'll kind of set that up. Remember, summary stats, columns, and I can do the mean and the standard deviation that way. But like again, I don't need it. So I'm going to go to stat, Z stats, one sample, but this time the choice is with data. Remember, last problem was with the summary. So with the data is in column 1. Remember, my mean equals 13. My mean is not equal to 13, and my standard deviation is 6.2. And when I click compute, and again, I get a z-stat of 1.03 and a p-value of 0.303. So that is enough to answer all the questions that I have going forward. Let's go ahead and close this and go back to our document. And here's the answer, the final answer, what it looks like in statcrunch. I wonder, can I make the print a little bigger? Okay, I guess I can't. So let's look at what we've identified. Here in part A, we have the mean equal to 13, and that's the claim, and the alternative hypothesis not equal to 13. With the test statistic, the standardized test statistic of 1.03, that's identified there. P-value of 0.303, rounded to 3 places. I was a little more careful with my rounding this time. And so what's my decision? Well, we know I'm going to fail to reject. Now remember, fail to reject is part of making that decision. There is not sufficient evidence to reject the claim that the mean time it takes smokers to quit smoking permanently is 13 years. We don't have enough evidence to reject the claim. And because the claim is in the null hypothesis, and since we failed to reject the null hypothesis, that means the null hypothesis, as we said, it had to fly. So that is how you would complete this problem. I think the biggest trick here is remember to enter the population standard deviation. And don't forget to put your hypothesis test in. You kind of get in a hurry. So I hope you'll find this helpful. We're going to have 3 more videos for this section. The next 2, we're going to work with population standard deviations unknown, and then the last one will be a hypothesis test for a proportion. Good. Hope you found this helpful. Good luck.